know this is so because
this meeting is being recorded.
The green GDP does not improve the welfare. So GDP is an indicator of improved welfare actually. Okay? Every year, if you claim that the GDP has increased by 7% compared to last year, that means that 7% of your welfare has increased this year, right? But when we deal with environmental defensive expenditure, what happens is that it does not increase the welfare, but it only prevents the welfare from getting affected. It maintains the welfare over a period of time. If you look at the nature of this defense expenditure, then buying electric vehicles is a defense expenditure. Buying alternative fuels is a defense expenditure. Now the question is, over a period of time, the literature suggested that you cannot net out the entire defense expenditure because the environmental activities or the activities pertaining to the environmental protection measures as such generate benefits in the economy in terms of tax revenues, in terms of kind of health benefits, in terms of employment. For example, there is a huge potential for generating employment in the environment sector, especially in that particular sector where the equipments for kind of defensive measures, environmental defensive measures like electric vehicles, etc. So therefore, we have to focus on the environment-related economy as well. Okay, so that is the kind of focus of today's talk by Professor Deepak Rajagopal. Professor Deepak is an associate professor at the Institute of the Environment and Sustainability, University of California, Los Angeles. And he has got his PhD in energy and resources from UC Berkeley, Master of Science in Agriculture and Resource Economics from the same university, UC Berkeley, and he is indeed an engineer turned economist, and he has got his mechanical engineering degree from University of Maryland and a bachelor's degree from mechanical engineering IIT. So he is visiting his alma mater today. And prior to joining University of California at Los Angeles, he was a postdoctoral researcher at the Energy Biosciences Institute, UC Berkeley, and still he is also associated with that particular institute. He has 3 years of experience as a structural engineer at the United Technologies Research Center in Hartford, Connecticut. His fields of research include industrial ecology and life cycle assessment. Many of us don't work on life cycle assessment here in India. And energy economics and policy. He is also the faculty director of the Leaders in Sustainability Graduate Certificate Program as UCLA, and some of the youngsters may think of joining this program also in the future. So on behalf of MIDS and on behalf of all of us, I'd like to invite Dr. Deepak, and now Deepak, please.
If you don't mind, just stand there.
Please.
Yeah, I like to stand and just move around.
Yeah.
All right. Thank you, Professor Venkat, for that introduction. Lovely introduction and kind words. Also, thanks for this opportunity. Really happy to be here. It's very nostalgic every time I come back to this part of the city. My parents now live in Bangalore, so but I don't miss an opportunity to come back to Chennai. I grew up here. This talk again, I hope you find it some connection to what you do. I'll try my best to relate it. To an engineer, I sound very much like an economist. When I talk to an engineer, they think I'm an economist. When I talk to an economist, they think I'm more like an engineer. My PhD was an interdisciplinary program. So I'm not a card-carrying economist, but my PhD supervisor was an economist. And I think very much like an economist. I do benefit cost analysis of every decision I do. I draw up a spreadsheet. I mean, I don't quite quantify it in dollars, but I add up the costs and benefits of every decision I make, and but I don't make decisions purely based on that. So this topic, and just a little bit about what life cycle assessment is, and why economists. It's very intuitive to economists. If I relate it like a sort of like it's like general equilibrium analysis. And what life cycle analysis, how it differs is, you're not looking at economy-wide or just purely on monetary impacts, but it's more an engineering approach. So it's focused on individual products, cars, or buses, or a specific food item, a water bottle, a building, and look at the impacts of that from raw materials all the way through its end of life. That's okay. All the way through its all the way through its end of life. So you look at not just so if you look at as an economist, if you're thinking of a carbon tax, you will think of putting a carbon tax on the pollution that comes out of burning petrol, essentially out of the pipe of a car or the smokestack of an industry. So you'll only look at a carbon tax applied on what you emit, right? In life cycle assessment, you would think of applying a carbon tax not just on the pollution that comes from petrol burning, but the pollution, the polluter also pays for the pollution that comes when you extract the petrol, extract the oil, transport it, refine it. So, so you're not responsible only for what you directly pollute, what you're also responsible for polluting. So the similar idea is like, putting border adjustment taxes on carbon. If you're doing a carbon policy, you want to put a border adjustment tax based on how much pollution is there in the imports and so on. So life cycle assessment is useful if you're doing an incomplete carbon tax. So if you just put a tax on carbon and only penalize one part of the supply chain, you might be increasing pollution somewhere. So an example is electric vehicles don't have any pollution when you drive, but there is pollution when you make the electricity. So if you apply a carbon tax only on the car industry, and essentially you're ignoring the increase in pollution in the electricity industry, and vice versa. Like another example is biofuels. We have a biofuel policy in India for 10 or 20% blending. If you ignore the pollution from growing of sugarcane or molasses or whatever, when you burn, the biofuel itself is carbon neutral because that is photosynthetic carbon. It was captured during photosynthesis. It's part of a closed cycle. But there is pollution associated with with growing the crop, fertilizers, and so on. So a life cycle assessment can help quantify what is the embodied pollution. So I think it's something that economists don't take very seriously, and there are good reasons. It's too complicated. Just put a carbon tax on everybody. Life is simple. You don't need to do life cycle assessment. But in reality, we are not putting an economy-wide carbon tax. Even if you put an economy-wide carbon tax, it's not a global carbon tax. So if one country puts a carbon tax, you can just import the carbon and not pay anything. So that's why I think a life cycle assessment is very useful. That was my PhD dissertation, was how do we introduce economics and behavior, microeconomics into life cycle assessment. So this topic on electric vehicles, again, I'm talking about a technology. Usually economists don't talk about technology per se. You're technology neutral. What is salient about one specific technology. But I again think that if you look around, policies are more complicated than they need to be often. If you see, ultimately we give subsidies for a specific technology. We support solar, we support wind, we tax petrol or carbon from one specific source. So we selectively always intervene in one sector or the other. And and if you look at the course of history, and ultimately it's individual technologies that have improved the quality of life and productivity. And so I actually think that we also need to understand, we need to look at technology by technology. We need to decide, okay, what is electric vehicles? What should our policy be? An economist again would say, just put a carbon tax. Two things, there is a pollution externality, tax it with carbon. If there is a learning externality, like a positive externality, you give a subsidy for research. So subsidy for research like encourage the good by giving an incentive, discourage the bad by putting a tax. That's what an economist would say. But if you do not have either, even if you have a carbon tax, you might need to selectively select technologies as winners. We have to make a strategic investment in electric vehicles, because tomorrow, if our auto industry has to be competitive, we have a very big auto industry, which is, if it has to stay competitive, and if the world is changing, we can't keep playing catch up. So we need to have a policy towards electric vehicles. We cannot say, wait and leapfrog, and that has cost us. Like in electronics, we are trying to catch up with China, right? I mean, so, and if you look at world around, I mean, this whole idea is that the state has had a very important role in picking winners. Of course, the state makes mistakes when it picks winners. There'll be some losing technologies, or there'll be like crony capitalism and all that. But this I'm talking about is at a much higher level. Okay, what should we understand about the costs and benefits of electric vehicles? And it's a very important technology. And the other thing is climate change and the energy transition is something we have to do. We have to embark on it, and the government has already promised a lot of things. It's all very, and the other thing in India is a lot of it is very electricity heavy. It's right now focused mainly on it. But if you saw about this Panchamrit announcement by the Prime Minister, they're also talking about reducing the carbon intensity of the economy by 50% or some number. And that cannot come only from electricity. You also have to transform agriculture, you have to transform industry, you have to transform manufacturing, you have to transform transportation. And transportation is one of the fastest growing sources of pollution. As people get wealthy, the first thing they buy is car. And so that's the context. And please jump in if anything is not clear. I'll go for 35-40 minutes, and then have a Q&A. So the motivation, again, the environmental benefits of transitioning. I think Professor Venkat mentioned about the importance of adjusting GDP for depletion of scarce natural resources, air quality impacts, defensive expenditures. All that is very important. And so the benefits of clean environment, better health, I mean, there is no dispute. The question is, it is not free. It comes at a cost, and there is an opportunity cost. We should, and again, ideally, we should be picking that gives the most return on investment to society. This is not an overall cost-benefit analysis. This is not even a cost-benefit analysis. I'm just doing a very descriptive analysis of, okay, in today's conditions, what does electric vehicles mean so ICE is internal combustion engine, it's just petrol and diesel vehicles. And what I'm just doing a very descriptive short-run analysis of how much we depend on the petroleum economy today in terms of government revenues. How much over the life of a car, how much taxes does a car generate? I think that's a very, to me, that was the exciting number that came out of this. Okay, every car produces so many lakhs of rupees in taxes over its life, which you have to make up for as a shortfall. So I'll just get to that number. But looking at cost, total life cycle cost of ownership, it's not just the purchase price. We have to look at the life of the car and how much are we spending, and how does electric vehicles compare? Tax revenues, employment per car. In every car, how many jobs are involved today? How much might be there if we switch to electric vehicles? Because it's different. Electric vehicles are much more simpler, and they have far fewer components, and they will need less maintenance. Okay, so mainly it's an intention to, there are a lot of people studying the energy transition, but this is more looking at, okay, the cost of the transition. The benefits are of course there, but the cost side of the transition. Okay, so why electric vehicles? I think it's one of the things. It's like a defensive expenditure, but it's not just that. It's actually a better technology, right? I mean, so it's two things at one time. It's less polluting, but if you've driven an electric vehicle, I don't know how many of you have, it feels better, and it's a much superior technology in terms of ride comfort. I've driven a car. I've not driven an electric two-wheeler. So again, in India, two-wheelers, three-wheelers, and buses. So India has done something good with its focus on electric vehicles compared to other countries, in that we focused more on two-wheelers, three-wheelers, and buses. We didn't. if you look at the flagship policy, it's called FAME, FAME, faster adoption and manufacturing. They brought it to the second phase, this government, 10,000 crores. 60% or 50% of the subsidy is for buses, city buses. So I was involved. I was just trying to work with the Department of Heavy Industries, and we gave some comments. And I think it's a really wonderful thing that they focused on buses first. There are a lot of reasons why you should. I'll say a little bit more about it. But this work is on cars. Okay, not very popular, but again, I hear that India should not focus on cars and stuff. But almost everybody who says that drives a car. Okay. So whether we like it or not, people are going to demand cars, and we need to make them clean as well. Right now, there is not that many subsidies for cars. There is a GST rebate. If you buy an electric car, I don't know if it's true for two-wheelers as well, but it's a huge difference. Petrol car or a diesel car, 29% GST. Electric car is 5% GST. And I'll show you how that affects the cost. So it's a better technology. It's potential. All of this needs to be borne out empirically. But the engineering analysis says it's lower life cycle cost per kilometer. It's lower pollution during use, actually zero pollution when you drive it, but increases pollution when you generate the electricity. So it's very important the electricity is clean. I'll show some numbers. It reduces energy imports. It can reduce its potential, and actually in this analysis, I will show that it does. It can also align with solar generation. So India is massively scaling up solar. If you can actually charge your car in the afternoons when you're not driving, let's say you're parked at work, parked at home, if you're not really driving, if you could charge the car during the solar peak hours between 9 a.m. where you get to work at 10 o'clock or 11 o'clock, from 11 to 4 or 5 until you get home, if you can keep charging it, it can actually charge at the same time as you're generating solar electricity. So you don't have to put too much batteries to store. Otherwise, the problem with solar is it's not available at night. So you have to put storage. It's costly. Batteries are getting cheaper, but this can help balance grid as well. The main challenge is it's costly. Electric technology is costly. Even with subsidies, it's costly. And we would like it to be cheap, but even if it's upfront costly, if it is lower cost over its life, that's a rational choice. So we should not purely look at upfront cost, and we need to work to figure out how do we incentivize people to look long run, not just at upfront cost. We are very present cost biased. Nobody wants to pay extra 4 lakhs and say, I will recover the cost. I'll pay 4 lakhs now. It'll save me 8 lakhs over 10 years. Most people say, okay, that's not a worthwhile bargain. I would rather spend less because I don't trust the technology. It's too long to wait. There's the opportunity cost of capital. So you have to subsidize the loan. You have to give low interest rates and so on. So there are some policies like that. So there is a lack of charging infrastructure. I mean, that's a huge thing for public investment. I mean, the classic public good, or it's like a not so much a public good as much as it's like it's something that has huge network effects, network externalities, and so there is a case to subsidize it. New pollution concerns. You have battery-related toxics. You're shifting pollution from cities to rural areas where electricity may be produced in power plants areas. It's less labor intensive. I'll show some numbers. It takes less people to make electric car than to make a petrol car. But independent of that, actually, auto industry is going to see a decline in jobs intensity because of automation. But this could be on top of that. Automation plus less people needed, and then impact on public finances. So hopefully that part is interesting to you. So in terms of the approach, I just use an incremental cost. I'll say what I mean by that. I use information on cost, import content, taxes, tariffs, subsidies, jobs intensity from the annual survey of industries. And I analyze a scenario of 10% replacement of new car sales. What if 10% of new car sales are electric instead of petrol, ICE short? And then I do a performance sensitivity analysis and discuss some potential options. Okay. So it's a very, in terms of caveats, this is a linear analysis. So the effect of 100 electric cars is 100 times the effect of 1 electric car, or the effect of 1,000 electric cars is 1,000 times the effect of 1 electric car. The linear analysis, fixed proportions. Obviously, that is good for the short run. In the long run, fixed proportions is not a good assumption. Things change. You have to be more parametric. technical change and adjustment of inputs and so on happen. So it's primarily accounting. Accounting is not as exciting, but I think it's very transparent. And that's the good thing about accounting, that it's a very good baseline. It's established, okay, this is the linkages today, and so that's where it's useful. It's a starting point. It's not the definitive word on what will be the impacts of electric vehicles in the long run, but what are the impacts? What are the connections to it? I put a carbon tax to monetize the greenhouse gas benefits. Air quality, I'm not monetizing here, and there is some work to be done. That's a limitation of this analysis, and I'm not doing a benefit. So I wouldn't say I wouldn't draw strong normative welfare implications because of the nature of the analysis. Okay, so just to give a little bit of technical information on electric cars, this picture actually shows what are the components that are not needed in an electric car. So it doesn't need an engine. Okay, it doesn't need a lot of other engine components like cooling. Engine cooling is not needed. Battery cooling is needed. But transmission, you don't need a very complicated transmission that takes from the engine. So essentially, the engine is an internal combustion engine. The engine's motion has to be translated to the wheels through the transmission. That's what the transmission is. It's a pretty complicated device, costly. So you don't need all of that, because what they do is you just through a wire, send electricity from the battery to the wheels. There is a motor right on the wheel or on the axle, and that spins. So it eliminates all that. So everything in this picture except the wheels you still need. Other things are gone. You don't need it. So that's about 100 components you don't need in an electric car. Some of the most expensive parts of a car: engine, transmission. So if you're an auto industry, these are all like the more expensive components. And so all of this is needed. Okay, not needed. And what you're gaining some battery pack right at the middle, at the bottom, and then some powertrain and all that and so. But on net, it has 60 fewer components. Okay, each of those components has sub-components, right? So whole systems will not be needed now, and this is huge impact. Like the auto industry's linkages are huge because to the suppliers, to the big disruption could happen there. Okay, and the core intellectual property is the engine. And instead of now making auto companies now need to learn to make completely new technology called batteries, which is completely different type of science, and it's more chemistry and electronics, not engines and fuels. So what is the cost of all those things that are not needed in the car? The powertrain is the right at the top, is the thing that you don't need, and that's about 30% of the cost. It's 25%. I use 30% because this is a number from the US. In India, it is more because labor is cheaper. So capital or components as a share of car cost is higher, but it's about 25% to 30% of the car is now not needed. Okay, there's a huge impact. So I assume a price. So how do I? So what I do, I take the price of a petrol car in the market price. It's a huge range. You have cars from I think 6 lakhs to 15 lakhs to 20 lakhs. I took the middle 9 lakh car. Okay, not a luxury car, but a typical car, 9 lakhs. So then from that I subtract out OEM, original equipment manager. So Hyundai or Toyota or Maruti, the OEM, the car maker's margin. There is a GST, there is a dealer margin, there is road tax, registration. All of that is around 3.5 lakhs. So 9 lakh car, 3.5 lakhs is all those things. So if you subtract that out, then 5.3 lakhs is like the cost to make the vehicle for the automaker. That's what it costs them to make it. So for margins, I assume like 5 to 7% margin. That information is hard to get, but people have mentioned like companies make 5 to 7% margin. Dealers make like 5% margin, 4 to 5%. The rest is all public information. GST is 29% as well. I assume the powertrain is 30% of that 5.3 lakhs. So remaining 3.7 lakhs is the common for both cars, electric cars, and the starting point is that. And to this, I will add the cost of battery and build up the cost of the electric car. Okay. So before I do that, I'll just show one thing from a petrol price. If you're paying 100 rupees for petrol, about 45 rupees is taxes in petrol. Okay. Central excise is around 25 rupees. State VAT is 20 rupees. So on 100 rupees, the state and the central government make 50 rupees. So 50% is taxes. Huh? Says, everything is included. Everything is included around 45 to 50%. During the, I saw a statistic during the when the COVID started, the peak of the COVID, when oil prices fell to 40 rupees or 16 rupees a barrel. I think the government didn't pass on the benefits. They still, maybe it went down. At that time, the taxes were 67% of the price of petrol. So the government made a lot of money during the pandemic. 67%. Now it's come down to 45. It was at 50 when I started the paper. It's been coming down to it's now 45%. So 45 rupees. So keep that in mind because that is taxes lost. So in the public finance, they call it as tax expenditure, revenue foregone. So and share of imports. So about 35% is the cost of crude oil in 100 rupees. And imports are 80%. So 80% of 35, about 30 rupees is the imports. So if you pump petrol for 100 rupees, you pay 100 rupees, 30 rupees is actually what you're sending out of the country to Saudi Arabia, Iran, Iraq, or whoever. That's like a huge outflow. Okay? And about India's largest imports is petroleum. Okay. So people talk of a carbon tax. If you put a carbon tax, what effect it will have on the price of petrol? Each unit of petrol has about 3,420, 3.5 kilograms. In every liter of petrol, there is 3.5 kgs of carbon dioxide when you burn it. So if you put a carbon tax of $50 a ton, that amounts to about 15 rupees a liter. So if you put a carbon tax of $50 a ton, it will raise your petrol price by 15 rupees. Okay. That's 1/3 of the 50% we already pay. We pay 50 rupees in taxes, 50. The carbon tax will add 1/3 of that. Okay. So if you have to recover all the revenue loss through a carbon tax, you have to put a carbon tax of $200 a ton. It's a huge carbon tax. So the implicit price of the carbon tax. Okay. Battery price, just some information. India is trying to make batteries. Today, the thing is, if you look at a car, we make all the components. Practically all the components of the car is domestically made in India because of the policies we enacted in the 1950s through import substitution. So we have a thriving auto sector because the government in 1940s and 50s decided that this is a very important strategic sector. Right? Now we have this. We have to have something similar if you want to build up an electric vehicle industry. Some people will say this is too costly. It's not a rich country technology. Wait for it and leapfrog. I don't think we can afford to do that. We should start. We're already late to the game. China is already leaps and bounds ahead. Okay? They're locking up supplies of lithium. We don't have a lot of the minerals and stuff. We don't. So this blue, this light blue on the right is what we import largely from China. China is where we are importing the cells. So if you look at an electric car, if you have a torch cell, like the everyday cell, it's very similar. That's what is there in the car. About 2,000 of those is what is sitting inside. If you're inside the car, if you heard of a Tesla as a company, their actually car cells are actually like that. They have 2,000 of those everyday kind of cells, except they are lithium cells. It looks the same. So that we have to import. Then you have to assemble it and make it into a part that we can make it. That we make in India now. The assembly happens in India, but the original cells are imported. And the government of India is now trying to, with the Atmanirbhar and the production linked incentive and the PLI scheme and Make in India, I think they're all sort of connected. They're trying to build that up with huge subsidies. I think Gujarat got a huge investment from Samsung or something. 2 big battery manufacturing plants are being set up in India. It'll take time. So then I started with this, right? So 25 minutes, I should go faster. So I started this number, 3.7 lakhs. Oops, sorry, 3.7 lakhs. Now to the 3.7 lakhs, I add the cost of the battery. Okay. So battery, essentially I add $200 a kilowatt hour. If the car goes 200 kilometers, how much battery you need, and so on. This is the main number. I come up with a cost of 13 lakhs for the electric car, 12.6 lakhs. It's shown in millions, 1,259, shown in millions. I know we use more lakhs in India, so it's the 12.6 lakhs to 13 lakhs. So 9 lakh petrol car, 13.5 to 13 lakh electric car. So 4 lakhs more. So it's 43% costlier upfront. So just some numbers on how many cars we sell in India. This is from source from SIAM, Society of Automotive Manufacturers. We sell about 30 lakhs of cars every year. We sell 30 lakh cars every year. It's growing every year. Just one number on the, sorry, just one more thing. In terms of individual vehicles, two-wheelers, 1 crore and 34 lakh two-wheelers we sell every year. Way more two-wheelers we sell. Okay, but each has a very tiny amount of battery, small amount of battery. And I think we're already producing, we're going to, already the change is happening with two-wheelers. Cars needs to happen a little bit. It's also happening now. So just to give you some statistics on how much we import petrol, how important petrol is, it's about 30% of all imports is petrol. Second is electronics. So electric vehicles are reducing petrol and increasing electronics imports. Just one more picture on the background. This is all background information that goes into the analysis. And it's very simple. It's a linear analysis. It's all spreadsheet. It's all just a Microsoft spreadsheet. There's no very simple arithmetic calculation. There's no complex calculus or algebra or any kind of thing. So annual survey of industries, this tells me for each of those sectors, oil, auto, electricity, batteries, installation, NIC stands for National Industrial Classification. In every lakh of rupees, how many jobs are there? So just to give an example, in 1 lakh rupees of oil, there is 0.11 job, annual job. That's it. 1 lakh of oil sales involves 0.11 man hours of job annually. Man years. Just to see, look at auto components, the third row, ICE components. I can do this here. Yeah, this one. Oh, it's not showing the arrow there. Okay, that's fine. The third row, 0.0268. So if you look at the auto parts, oil extraction is 0.11, auto components is 0.03. So 1/3 less labor. It's very high for crude oil. I don't know why it's so high. Usually you would think raw material extraction is less and manufacturing has to be higher. I don't know, but it's from the annual survey of industries. Interestingly, if you see refined products, which is refining of petrol, it's even smaller than auto manufacturing. So there's not that many jobs in oil refining actually. And if you see, here's a very important point. If you look at the life cycle of a car, I'll show the number. You buy a diesel car for 9 lakhs and you use it for 10 years. You will spend about 10 lakhs on petrol. And 9 lakhs car, you spend more than what you buy on petrol, which is imported. And if you see, and so it has very less jobs. So here's the thing, right? Petrol is imported, huge drain on foreign exchange, and extremely less labor intensive. Look at electricity, power generation, right? So what are we doing with electric cars? We are refining less petrol, making less oil products, producing more electricity. Look at the labor intensity of electricity. Coal, not power generation, transmission and including 0.023. Okay, so it's much more labor intensive compared to refining. So it'll create more domestic jobs. Okay, so any reduction, so there'll be a shifting. I mean, so this will be a big game changer, right? You will need new types of jobs because if you're going to become a more electrified economy, you're going to need a lot of jobs in the electricity sector compared to the, and there's some health benefits, right? People working in the electricity power sector don't suffer the kind of health impacts that people work in toxic chemical industries suffer, right? These are all big important impacts. Quality of employee health. As development economists, probably you care about a lot of those things, right? Those are very important development outcomes. Less health damages, less time lost due to sickness, increase in productivity, less exposure to toxic air pollution. These are huge things. Actually, now increasingly, I think the biggest weakness of my work is I'm not monetizing those things. I'm monetizing all the other things actually. So that's future work. So I use that number. I compute how much rupees of petrol is there, how much rupees of auto components is there, how much rupees of batteries are there over the life. and I multiply it to compute how many jobs are there in a car compared to electric vehicles. So I'll show all those numbers. Oh, sorry. One more picture on the background. These are the 5 taxes I consider: GST, road tax, fuel tax, which is excise and state both combined, central excise and state VAT, GST on repair and maintenance, income tax deduction on, if you take a loan out for electric car, you can get an income tax deduction of up to 1.5 lakhs. And then there are some assumptions. Discount rate is very important for any long run calculations. 10%. Vehicle life is 3 lakh kilometers. Carbon cost is $50 a ton. Yeah.
I think the vehicle life in India is very
No, it's higher. It's too high.
Yeah.
3 lakhs probably. So essentially, yeah. I mean, those road conditions are bad and stuff.
Comparatively, if you talk to a dealer, for example, I know.
So this is for a car though.
Yeah, for a car.
India
people go drive for 300,000.
No, yeah. So what I mean here is, it's not the ownership. You may own it, but maybe there is a second life. So this is, I don't have a salvage value. So I may own the car only for 5-6 years. It becomes a little old. I sell it off and switch to a new car. That car is not going to be totally junked. Somebody's probably going to drive it. So even still, I agree. This is probably too much of a life. Yeah.
Like the vast majority, of people I know, hardly if you just take a survey, nobody exceeds 100,000.
1 lakh. Yeah. So,
1 lakh.
Yeah, good point. Good point. Good point. I'll do a sensitivity to it. Okay, that's a point well taken. So one other thing is I'm going to do a lot of sensitivity. If each of these numbers change, how does the comparison? So I'm going to do electric versus petrol and change each of these numbers. I haven't done all of that. I haven't done that, but I'll show you a few I have done. But that's a good point. That's noted. Okay. Anything important here is, yeah. I mean, I know this is not an electric vehicle crowd, so I won't bore you with it. But if you want any information on electric vehicles, I'll share. I made reasonable assumptions, but they're all uncertain. This is a new technology. It's going to change. It's very hard to predict what it's going to be like. Petrol is a 100-year-old technology. There's really not much that's going to change in petrol. It's a new technology. So this is the first set of results. So now we will go to the next 4-5 slides results, and then I'll stop. Yeah.
You have put the cost sheet for petrol is 8 point something.
The cost of?
You told me cost 8.5 lakh something.
Petrol car.
Petrol. Out of which 3.7 is common to both.
Common to both.
So what is the saving for me if I shift to EV?
Yes, I'm going to show you. Yes, I'm coming there. So when you buy, you will pay 4 lakhs more. Okay, it's 13 lakhs, not 9 lakhs. But I'll show you over the life. I'm coming there. That's one of the key results. I'm coming there after this.
Okay.
After this, next one. Emissions per kilometer. So per kilometer, how much pollution is coming? So life cycle greenhouse gas, not just when you drive, but whole life cycle. To make the electricity, to make the battery and drive, and for petrol to extract the oil, ship it, refine it, and burn it. So petrol cars using India's average electricity mix. So India's electricity mix is 70% coal in generation. 30% is non-coal, mostly renewables, little bit of gas, hydro, nuclear, but mostly now fastest growing is solar. So there's a weighted average. I'm not showing that number. It's around some 700 grams of carbon dioxide per unit of electricity. I multiply that by how many kilometers you can go per kilometer per unit of electricity. So petrol is very straightforward. It's 190 grams of carbon dioxide in every kilometer you drive. Electric vehicle already with 70% coal, you're 112. So even with today's electricity mix, carbon emissions, which are important for climate change, are lower for electric vehicles. But other things are a little high. So petrol's NOx is nitric oxide, SOx is sulfur oxide, PM is particulate matter, that you feel like all the particles. So PM really is bad for your lungs. Air quality, a lot of NOx and SOx are also very bad. They cause ozone and all that, health problems. The thing about petrol electric cars is the cars are getting very clean because of Bharat State 6 and Euro 6 and stuff. Each car emits less, but simply because there are so many vehicles on the road, the cars have gotten cleaner. But since the number of cars has increased, you're not seeing an improvement in air quality. But on the per vehicle basis, electric vehicles are double the nitric oxides because it's coal-based electricity. But an interesting difference is your cities will be clean, but where the power is produced might get dirtier. And so the people around there may suffer. Yeah.
I think this petrol thing, right? Like there's this new thing of putting 10% of
Ethanol.
ethanol in it, but I'm not too sure if they accounted for the agricultural water usage.
Oh no, yeah, that's a huge deal. I mean, that's another topic. If we start comparing biofuels, hydrogen, with other alternatives are biofuels and hydrogen.
Yeah. So the ethanol here is
Yes.
sugarcane based.
Molasses.
So because of excess production.
Yes.
But it's not here the water component. So essentially it's water. You draw it
Right,
water from
right.
the
Sugarcane is very water intensive.
So the water
Yes.
and the pump sets are
Right.
basically driven by.
And there is huge social cost of all that free electricity.
So what I'm
Yes.
driving at here
Yes.
is that I'm not too sure if this number includes that water component. You know, when you're importing it one thing.
Yeah.
Because you're
There is no water. Water is never impact. Or you're saying the water's impact on nitric oxides.
No, the water drawn because of the agricultural.
Right. But there is, so petrol has 10% ethanol, and that ethanol has molasses. That molasses used water.
Correct.
So water is another dimension, embodied water. I think that's a good point. I mean, the water impacts probably we should start adding because petrol is coming. That's a good point.
Because the one we are importing doesn't have that water cost.
That's true.
Whereas this one
Has a
if you're
domestic
adding
water
10%,
cost, 10%.
this is going to
Yeah.
dramatically
So there are other impacts, right? Greenhouse gases, nitric oxide, sulfur, particulates. You can add water. You can add hazardous pollutants like, when you refine petrol, you get a lot of carcinogens, cancer-causing chemicals. They're called VOCs and so on. So there are 10 different environmental impacts. I'm not doing all of them here. So if you do a true life cycle, you have to include all of that as well. Absolutely. Yeah. Okay, this is the total cost. So what I do is total cost of ownership is I take the upfront cost, then every time you drive, you fill petrol, and over the life, if you have to figure out per kilometer how much are you paying. So essentially you're normalizing the upfront cost and the petrol cost. So the petrol per kilometer is very easy, 100 rupees a liter. You go 15 kilometers a liter, so it's 6.5 rupees per kilometer. But upfront cost, how do you do it? So the car is 13 lakhs or 10 lakhs and you drive 100,000, 1 lakh kilometers, you can get some number. But the fuel cost is happening over time. So you cannot add money over time, right? You have to discount it. So I take the upfront cost divided by the life of the car. So per kilometer, what is the upfront cost? Then petrol, it happens every year. You do a present value calculation, discounted present value. So that comes to about 14 rupees per kilometer for petrol car. So 14 rupees per kilometer for a petrol car, for a 9 lakh car. Electric vehicle comes to 10 rupees a kilometer. So it's costly upfront, 40% more costly, 4 lakhs more you pay, but per kilometer it's 4 rupees cheaper. So the more you drive the electric car, very quickly you get back the savings. So you're saving 4 rupees on every time you drive the petrol car, for EV electric car. So it's a 28% reduction. That's the last column. So if you break that cost up out of the 14 rupees or 13.7, I mean 13.7. So if you're looking for 14, I should be clear. There is no 14 there. It's 13.7, 13 rupees and 70 paisa. Out of that, 4.4 rupees is the cost of the car. Okay. 5.56 is the cost of petrol. So if you look at the life of the car, 30% is the cost of the vehicle, 40% is the fuel cost. So it's more important than the upfront cost of the vehicle. Maintenance is 20%. So if you look at the life of a car, 30% of the petrol car is per kilometer cost is vehicle, 40% is petrol, 20% is maintenance. Carbon cost is small, if you put a carbon, there's no carbon cost. Which I'm saying, if we put a carbon tax, that will be like 70 paisa per kilometer carbon cost. Electric vehicle, it's all in the upfront cost. 6.44 out of 9.88 is 60%. 60% of the operating of the life cycle cost of the electric vehicle is actually the vehicle itself. It's very cheap to operate because electricity is 6.5 rupees 1 unit, or 6.5 to 7 rupees 1 unit for the household level. Maybe I'm wrong. I use 6.5 rupees. I don't know how much you all pay per unit of electricity. Something like that, right? 6.5. Maybe that will go up in the long run, because if everybody starts buying electricity for cars, the electricity price has to go up. But I'm keeping that fixed. I'm assuming 6.5 rupees per unit in your house to charge it. Each unit will take you 7 kilometers. You can go 7 kilometers in 1 unit. So 7 rupees a unit, 7 kilometers, 1 rupee per kilometer to drive an electric car. Petrol, 7 rupees per kilometer, 100 rupees a liter, 15 liters per kilometers per liter is around 6.5 to 7. So huge saving in operating cost. So that's the challenge, is to get people to buy a costly technology and wait and get return. That's the main challenge with electric vehicles. Get people to invest. So change in government revenues. I'm at 40 minutes. I'll try to stop in 5 minutes. Government revenues. So what is the change in revenues, right? The vehicle, they collect less GST. 29% GST for petrol, 5% GST for electric vehicles. Today, tomorrow they might change it. As people buy electric cars, government will raise the GST, I think. So it's around 1.2 lakhs, 119612, 1.2 lakhs less GST per car. Road tax less 20,000. So this is the difference. Negative means it's less for electrics compared to petrol. 5 lakh less, so 495612, third row, almost 4.95, 5 lakhs. 5 lakhs less excise tax. Plus VAT. Sorry, it's not just excise. Excise plus VAT. Excise is for center, VAT is for state. State, petrol and liquor are the two things that the state makes a lot of money on. Okay, so it's also very interesting for the political economy of center-state relations. Eventually, you have to look at and say what it does. All these electric vehicle push from the government is actually reducing revenues for the state. They depend on the VAT. And they're talking of bringing the electric vehicles, petrol under GST, under GST. I think the states are going to oppose it. So excise tax plus VAT, about 5 lakhs less per car. So if you think of the price of the car, 9 lakhs, it's generating 5 lakhs less of taxes. Maintenance goes down because electric vehicles need less maintenance. You don't need oil change. You don't need oil filter. No transmission fluid. None of those things go out. Of course, your batteries will have to be changed. I include the cost of replacing batteries. Brakes last longer because there's regenerative braking. You don't brake the car electric much. So when you brake an electric car, it actually works based on magnetic braking. There's no physical wear and tear, so there's less wear and tear on the brakes. Brakes change can be costly and so on. So less maintenance per car, and so less GST from maintenance. So 50,000 rupees worth of GST comes from maintenance for the government. That also goes down. Import tariffs go up because there is a 5% tariff on battery imports today. Income tax interest deduction is a loss to the government of that. So if you add all of that, there is about 7.5 lakhs less in taxes for the government. And then add a carbon tax, about 60,000 less. If you add a carbon tax, there is less carbon electric vehicles, so you get less carbon tax. Okay, if you had a carbon tax. But carbon tax, if you add a carbon tax, it can raise revenues because there is so much more petrol being consumed. You'll get more revenues on the other petroleum that you sell. But for every electric vehicle you sell, instead of a petrol car, you will get less carbon tax. That's around 60,000. So collectively, it all comes to around 8 lakhs less in taxes per. I think that's the key result. In today's situation, the government is supporting. So if you ask how much is India supporting electric vehicles, it is supporting by foregoing taxes worth 7.5 lakhs on electric cars. So if you look at the Tata Nexon or somebody, when somebody buys a 13 lakh car, who buys it? Only a rich person buys an electric car. The 13 lakh car buyer is actually getting the government is losing around 7.5 lakhs of income tax, of various types of taxes. I mean, I'm not saying it's bad. It's a very important technology. You have to subsidize it, otherwise nobody's going to buy it because it's a strategic investment for the long run. But it's important to know we are a poor country, we're not that wealthy, so it's just to know how much we are supporting it. I mean, and so when I did this analysis, I'm saying, okay, India being a poor country, we need those taxes for a lot of social spending, social schemes. This is money foregone, and so something to desire. I don't know what you want to make of it, but sort of employment. So quickly, per 1,000 cars, because it's a small number of vehicles per car, people per small number of jobs per car. So I have to doing it in thousands because otherwise you have to carry a lot of zeros, just to make it easy on the eye. So for every 1,000 cars in a petrol car, there is a total of 64 jobs. 64 jobs per year in making 1,000 petrol cars, 63.69. Out of that, 43 is vehicle production. Around 68% is vehicle production. Fuel is actually very little, 3%. Maintenance is around 28%. For the electric vehicle production, so total jobs, the last column, negative 24%. So less jobs per car. And that basically comes from the fact that you have less components in the car. It's a more expensive car, but it has less components. So, that's the thing. It's a more expensive petrol. So if you look at a more expensive petrol car, it might have more money involved in it. So if you scale based on the number of people per rupees, you'll get more jobs. But because there is less components, even though it's costly, it has less jobs per car. I don't know, maybe it's based again. It's simply based on the thank you, annual survey of industries. I don't know if any of you use that data source in anything for the development studies. I'm not a development economist or even a labor economist. I don't deal with it. I was just looking for this information. I found this. I don't know what you think of the quality of the data. I don't know. We can talk later. But if you have any suggestions on where I can find good jobs numbers or good labor intensity, please, I welcome that. Okay.
Fuel employment.
Yeah.
Does it include number of people employed in the petrol pump?
Yeah. So that's why I had the refining. It's a good question. That's a good question. Yeah. Maybe I'm missing that.
Will be replacing all the.
Yeah. So it'll actually, I think I'm missing that here. Good point, actually. That and the water. So I should note down that and the water. I have to add. Okay. So summary. I'm summarizing on the left. Life cycle cost. So that's what the term is, life cycle cost, which means you don't look just at the upfront cost or the petrol cost or everything together is life cycle. And you should think in life cycle terms because otherwise you're missing. You can't just look at one of them, not just for upfront, not just operating. But most people think like that. When you buy a car, you just look at, okay, how much is the car costing? You really don't think what is its life cycle cost. And when you do a life cycle calculation, if you can afford it, it's probably worth getting an electric car. Only thing is, of course, there's some charging issues. You have to figure out if you have to go to Mahabalipuram or maybe Mahabalipuram you can go and come back. But if you're going to go to Bangalore and come back, where will you charge it or something like that? The charging is the big barrier, I think, today. So if anything, one message is, government should spend more on charging infrastructure rather than subsidizing vehicles. Because charging infrastructure can benefit everybody. The vehicle benefits one person. The charging infrastructure benefits society at large. There's network effects. There is all that, right? So one of the messages is to that support charging more. If you support charging, automatically people will buy the car because anybody who drives the car, you'll realize it's a superb thing to drive. It's quiet. I mean, I drive it. I'm totally. So I bought a electric car and then I just don't want to drive the petrol car. It's just much better experience. It's a better technology. So, just on all these things are summarized. These are like things we care about, multi-criteria assessment. I mean, as ideally, if you're doing a cost-benefit analysis, you can put a dollar number or rupee number, rolling all of it up. I'm not doing that. So the last column is showing the change. So life cycle cost. So it's cheaper over the life. It has less carbon emissions. I don't have air quality yet. Imports are lower. Government revenue is lower by 79% per car. jobs lower by 20% per car, and pollution is lower by 40%. So there are some trade-offs. There are some good and some bad, mixed messages here. So just some sensitivity, and then I'll stop. So there are a lot of assumptions. There's like 25 different numbers in the thing. I have to. So the base case results are here. On the top, base case plus carbon tax. What if the battery got cheaper? Instead of 200 rupees, the battery becomes half. It's good news for electric vehicles. You will save more money. Vehicle use. If you use the car more, electric car looks even better because you're driving more, you're saving more fuel, spending less on fuel. And fuel is the cheaper part for electric car. Of course, the battery will wear out sooner. So I factored in that battery has to be replaced more. But even factoring in the battery has to be replaced more because you're saving so much on petrol, it's even better. So this is the thing. If you electrify buses, if you electrify taxis, it's much better for society than individual cars of rich people. And so one of the things I have been trying to get the message out is actually India should focus on electrifying taxis and like the Uber, Ola, get them to electrify because those cars drive a lot and they can get quick payback. But the problem is they are poor people or too. You have to help them because it's as such a struggle for those drivers. They are stuck with loans on an 8 lakh car that they're struggling to repay. How are they going to repay a 13 lakh loan, right? So we need to help. We have to have some targeted policy to help those poor people because they drive a lot. And that's where the most of it, but it takes more work. It's more transaction cost, more administrative costs, right? It's easy for the government to say, I will give you a rebate on GST, but it's more harder to devise a policy for those people. Somebody has to, okay, we have to work with Uber and Ola and tell them, hey, so California, where I am at, is doing one thing. It is actually forcing. So Uber has to become 100% zero emission in California by 2030. So that's a mandate on Uber to go 100% electric or hydrogen, whatever. So the California state said, we don't care. You figure out. It's not my problem. Uber, if you want a license to operate, you have to be 100% electric by 2030. So we need some mix of heavy-handed sticks and some carrots. So carrot and stick. So some incentives and disincentives we need. So the main message is we need to focus on high use. That's why I think the focus on buses is a very good thing. Buses pay back quickly and it benefits everybody. And you can see anybody stuck behind on a two-wheeler behind a polluting bus will benefit a lot. There's a huge social benefit to us. So this is the last slide. Summary: EVs present trade-offs, and economics is all about trade-offs, right? I mean, that's trade-offs and unintended consequences. That's what economics is about. I mean, on other things, or at least I see it as a systematic way to look at trade-offs. So there is lower life cycle cost, lower pollution, and lower imports. But on the other hand, there is less government revenue and less jobs per vehicle. But we can address these things. It's not that it will, we have to plan for, if we are serious about an energy transition, we also have to be serious about how are we going to get revenues for the government. The government is actually talking, they're talking through both sides of the mouth. Essentially, it means that on the one hand, it makes money on petrol. On the other hand, it suffers because people suffer from the consequences of using petrol, both air quality wise. So it's a tough act. The real challenge is how are we going to do the transition? How are we going to one piece of good news is as economies grow, you might know, is the share of indirect taxes become less important. There's more direct taxes, like corporate tax and income tax. If you look at 20 years back, India's total tax revenue, 25% was from excise. Today it's only 12%. And that's because we have come to depend less and less on indirect taxes, and as because people get wealthier, income and corporate taxes become more important. So so there is some good news that as we get wealthy, you will get more of those streams of revenue that you don't have to depend so much on these streams of revenue. So it's not so bad. It's not such a pessimistic news. A lot of my friends who are like electric vehicle enthusiasts don't like this message. Oh, you're saying government revenues will go down and your people are going to, as such, people don't like electric vehicles. People might misinterpret. That's not the point. The point is today we have to start planning. That's the point of it. I think that's what I said. Like the excise taxes are 12%, and this throat is getting dry. I think that's it. In the long run, as India's economy grows, excise taxes will keep declining. But that may be a while. I think we have very good reasons, strong environmental and air quality and public health reasons to start pursuing electric vehicles. But it's a challenge. It's costly. The government has to figure out a way to get people to adopt it. That's the challenge. Okay, that's it. I'll take questions.
Risk associated with the petrol vehicle versus electrical vehicle.
Yeah.
Is there any analysis?
Yeah, it's a risk in terms of performance, like whether it's costly, it's unknown technology. Is that what you mean? Like risk in terms of
Because some vehicles recently
catch fire?
catch fire.
Yes, that's a good point. So there is a reason why that happened. I don't know if did cars in India catch fire or was those two-wheelers? So in the US, cars caught fire, and at that time the technology was you do some. So you have to cool the batteries. Batteries get hot. The cooling for cars was air cooling. So just like they were cooling the batteries by sucking in air and air-based cooling. Once they switched to liquid cooling, the fire stopped. So the way that the fire problem was addressed, I mean, there's still always a risk. It can always catch fire, but now you haven't heard any such news in America, at least in the so that was solved by switching to water-based cooling. In India, all those two-wheelers, I think, are still air-based cooling, and there's also design flaws. There is plus people not. I think there is a lot of design. There's always some learning by doing. So that risk has come down. I think already that news has died down now in India. It's a combination of factors. Extreme hot weather, not proper design. So we have to design batteries for Indian conditions which are very hot. So I think better cooling will take it.
It's covered by insurance.
Yeah. But it's a bad thing for the technology. For new technology, people are as such risk averse. They don't trust in new technology. You don't need these kind of things to scare people. And then people say, oh, the whole technology is bad. That's not true. So it's coming down. It's coming down. Hydrogen, the alternative is scary. You're sitting in a combustible gas in your car. But even that is safe. When electric hydrogen cars have been sold for a long time, then there haven't been any concerns about them bursting. But I'm sure one or two at some time will happen. Just statistically, that's going to happen. Yeah. Oh, sorry. Next.
Initially, I mentioned that we are responsible for creating pollution while extracting.
Yeah. Yeah.
In the same way, while saving
Yes.
lithium
mining.
batteries. So
Yeah.
lithium is actually very toxic to the environment, and we see that
there is. Yeah.
creates more pollution than the
So more, I don't know, right? How do you say more, right? What do you mean by more? Is the question.
I think it contributes to the toxicity of the water. And
Yes,
also
if you don't dispose it properly, absolutely, absolutely. Yeah, no, that is true. That is
that's
true.
very harmful to the human.
Yeah, if they dump, so if it is going to be mined irresponsibly, then it's obviously bad. So there has to be some safety and environmental standards on how lithium is mined.
And also the supply of lithium is very limited.
It-
So in the future,
There is a lot of it, yeah.
that the electric vehicles will grow.
Yes, so that is also true that lithium is also a finite resource, just like oil. If the whole world has to run on lithium, we probably have to tap into some really costly and environmentally damaging types of lithium. But hopefully, the thing is that this is a very new technology, right? Who knows whether 20 years from now whether we'll be using lithium? Maybe 30 years from now we'll be using lithium, but 40, 50 years there may be better chemistries. There may be like. I don't think so. I mean, that's a value judgment. You're putting some dollar value on damages from lithium. I don't know. I haven't seen damages on how damaging it is. There is always some pollution. Whether the pollution is worse than petrol, that really depends. It's hard to tell. Yeah. Yeah.
The last point in the summary.
Sorry.
The last point in the summary, you say replace the cells. So the cells after having been used, it will like e-waste.
Yeah. Correct. So the last point is about domestic manufacturing of cells. Uh, at the end of life of battery is also another important. Just as problematic, the mining of lithium, not just lithium, nickel, manganese, cobalt. You need a lot of them. Graphite. Graphite is not that problematic. It's just carbon. At the end of life is also a problem. But it won't be this. So just one thing that if you dispose it, just throw it away.
No, recycling is a trend now.
Yeah, it's not yet trend. We have to discuss. Yeah.
Many products.
Yeah.
And I happen to be work industry.
Yeah.
Recycling like electronic.
Tanning.
So it's without your brain or case we no, this you can link, you can think and you can exist. Some clue you can give for recycling the shell.
Yeah, it's a good question. I'm not an engineer. Yeah.
I'm a practical standard and economics.
Right.
I know I have studied economics also.
Right.
But I have come in this field.
Sure.
What might be good.
Right.
Then this you can kindly
Sure.
promote.
Sure. No, I think it's very important.
Yeah.
Very important. I think both the upstream extraction of lithium and the downstream end of life are both. So one solution is to have. So in Europe, there are laws called EPR, Extended Producer Responsibility. So whatever you make, you have to take back at the end of life.
Yeah.
So we need to have regulations saying that the manufacturer of the battery should own responsibility at the end of life. So what should happen in theory is when the car needs battery replacement, the dealer will take it, or a licensed formal, not just any mechanic, but a licensed person who can handle this takes it, because it's costly. No, it's not going to just put it in any corner shop. They take it, and then from them it goes back up to the company, and the company probably has some arrangements. Because of this regulation, they incentivize again. If the laws are there, a new industry will come up on recycling. So there's a lot of work to be done. You need laws, you need some engineering research, and a business model. All three have to happen. But here's one other thing: when the battery life ends for a car, it's most likely going to be used for stationary power. So that's a second life. So typically, there is already a lot of experiments going where, and after a car battery is used, it's going to be used for grid operation. So when we have solar in the day, nighttime you need something to store. Excess solar is going to be stored with probably used car batteries, and then that will die. Then we'll recycle. But recycling has to happen. It's just very costly though, if you have to recycle.
Technology of recycling has achieved a very high magnitude.
Yeah.
It's possible.
It's possible. Absolutely.
Very pragmatic and practical.
Definitely, because I mean, petrol is a 100-year industry. This is just 10 years. So if you give it 20, 30 years, there's a lot of room to. There was go ahead. I'll come to you next.
What are the challenges in creating a simple USB charger like open standard for
It's a good
charging
question.
infrastructure? I mean,
And
to me, I don't think it's too hard to do that. Right?
Yeah, I mean,
You mandate the
Yeah.
standard and then
that is something people are working on, because right now what has happened is the plugs, at least initially everybody had a different kind of plug in the US. So if you heard of Tesla has its own plugs. So Tesla charge, if you have a petrol car, every petrol car can use the same petrol station. Electrics, right? It's not like that. You need some adapters. Just like your laptop, you need an adapter from a Mac to a Dell. You need those adapters. So a Tesla charging station, if you have to use for a non-Tesla, you have to need an adapter. If you want to use somebody else, so there's this, there's a lot of combinations. But now industry is actually coming to us. There are 3 types of plugs, depending on how fast you charge. Extreme fast charging, one type of plug. Slightly slower charging, one type of plug. Very slow charging is a common plug. So there are 3 types of plugs. Everybody is coming towards that standard. So that has happened now. So your question of whether it's going to be as simple as plugging in a USB, I don't know. These are, if you've tried it, the fast charging, if you have to pump 50 kilowatts, if you want to do like a 50 kilowatt charger for cars, if you think about it, the Tata Nexon has about a 40 kilowatt hour battery, 40 or 45 kilowatt hour battery. So if you have to pump like 40 and charge it in 1 hour, it's a 50 kilowatt charger. That's like so, and the more electricity you have to pump, the thicker the cable, right? I mean, the more amperes. It's this heavy. You know, a lot of people cannot lift it, and like my mother cannot do it, or some young people can do it, but for old and it's not. It's very complicated. So we have to figure out a lot of things. We want to fast charge. We don't want it to be very heavy. We need some superior technologies that can carry a lot of current in a very small thing. That's another thing, because you have to charge buses and trucks. You're going to need 250, 300 kilowatt chargers. That's like very heavy. So, but yeah.
Because if you standardize that,
Standardize.
charging infrastructure will automatically.
Yeah, I think it's good. It's coming towards that. It's coming towards that. People realize now that it has to be. Every car maker is not making his own charger now. There is something called Bharat charger, and then there's this thing called CHAdeMO, CCS. Those are the terms. So there is some convergence to that. There are still 2 or 3 actually. It's not good enough. Maybe there should be 1.
Because what industry when the same moved, Apple was the.
Apple is horrible. Apple is the worst. They keep changing the adapters every year.
Now European Union has forced
Yeah.
them to adapt, right? So
It's horrible.
same.
The rest of them have good USB-C charger. Yeah.
Two questions. One is, we were talking about foregoing of revenue stream. So, in the short run, that's going to happen. Can it be compensated that if we become an export hub?
Yeah.
If we become a top
That is the
exporter,
rationale. That is the main thing, right? I mean, to get there, you have to. So it's a question of, to get there, you have to suffer some pain now. Nothing comes for free. So that has to be the vision. The vision has to be that we want to be a technology leader. We are subsidizing this as strategic industry. So China, if you look at battery charge prices, right? Battery prices were $1,000 per kilowatt hour. 1 kilowatt is 1 unit in your life. $1,000 per kilowatt hour in 2010. Today, international prices are 150. We are struggling at 150. We are not able to make batteries. China invested when it was 1,000. Think of how much money they strategically invested. They had this 25-year vision, because of which they are benefiting today. We are late to the game. We are starting now, like in a lot of things. Like we're trying to catch up in semiconductors and so on. But so we need that kind of strategic vision, which I think the government is now. You hear that a lot. That we want to be this kind of an economy. So that kind of vision has to be there, but also has to be backed up with long-term funding. And we have to keep at it. It's like going to take 10 years because these factories don't come up overnight. We have to get that. So there's the other thing. Why will there are 2 or 3 big makers of batteries now? LG Chemicals, Samsung, something like that. Panasonic. So we have to get them to come and invest in India. They are the 2 largest, and then BYD in China. Why should somebody come and set up cell manufacturing in India? Why? We don't have the infrastructure. So we don't have a domestic market. So how we have to create a domestic market and say that, hey, come and invest in India. Here's a domestic market. So I'm going to mandate that everybody is going to have 10%, like Ashok Leyland, Tata, Hyundai, Maruti. Everybody has to sell 10% electric cars. If you have a mandate like that, that's a guaranteed domestic demand. Now, as a battery manufacturer, okay, India has an electric vehicle policy. If I make batteries in India, somebody is going to buy it. And so once you have such a policy, somebody will come and set up. And once you create a domestic market and we get good at it, we can start dreaming of exporting. We cannot just say, come and invest for exports. I think why will they come? Nobody's going to come waste their time. So we have to create domestic demand. That is lacking today. We don't have a domestic. Investors need a strong signal. So I think that's missing in the policy ecosystem. Is the mandate is missing. Yeah.
how does hybrid cars fit in?
Yeah, hybrids. The thing is, hybrids are a good thing. Hybrids have both the same technology of an EV and a petrol tank. The good thing is you don't run out of charge. You can always, so there are different models there. So one interesting model is you have, because batteries were costly, the hybrid car was good when battery was costly. So it was too costly to put an all electric car. So what we did was we put like a small battery, like a Toyota Prius is the biggest popular car like that. It can take you within the city. When you go far away for long drives, you can just do the petrol car. So it is a good hybrid. So I use mostly in the city. That's where you get most of the savings because of the regenerative braking. So that was a very good thing when the batteries were costly. But now because the battery has become cheaper, hybrids are less popular because why have both? Then you have maintenance cost of both, right? I mean, it's neither here nor there. I know there is a crude saying in Hindi I can say, but but it's neither here nor there kind of thing, right? But there are some benefits to hybrids, definitely. It's still very popular in smart because it saves you money on petrol and you can go anywhere you want. So it could be a technology for the short run, but it still emits pollution and stuff. Huh? The hybrid is also costly. So it is not as costly as the electric car, but it also doesn't save you as much money as like electric car. So cheapest is petrol, costliest to operate is petrol, and the costliest to buy is electric, and cheapest to operate is electric, but in between is hybrid.
This is projection, right?
Yeah.
So you have you done or someone else done this projections for 3 years?
Yeah, there are. So actually, even for cars, they have done. There is the Council for Energy, Environment, and Water in Delhi. They are a think tank. They brought out a report looking. They didn't. So they only looked at total cost of ownership. They didn't look at imports. I don't think they might have looked at jobs, and yeah, they didn't look at taxes and stuff. So in terms of the cost savings and stuff. Yeah. So, I mean, this is based on actual price of an electric car. So if you see so 9 lakh car is a general car, but 13.5 lakhs, there is a Tata Tiger or the Mahindra E Verito. So the way I estimated my cost was to make sure I match with the real model of a car. So that's my first check is my price of an electric car is very similar to the market price of the Mahindra E Verito or the Tata Tiger. But then now there is a Tata Nexon SUV, which is 13 lakhs. Just the electric petrol is 13 lakhs. The Tata Nexon EV is 17.5 lakhs. That's also like 4 lakhs difference. So I just have to read on the calculations. But everything else is, basic numbers. So it sort of compares. Yeah. But, you have to complement this with a real survey of what people are using and finding and stuff. So that's a different work. Yeah. They are, yeah. So California, where I live, has banned new petrol car sales by 2035. Just now, ban on petrol car sales from 2035. So in 15 years, you cannot buy a non-electric car in California. Many other countries have done that. I don't know what that. That may be Saudi Arabia, I think, because they want to sell a lot of oil. I don't know. I'm just joking. I don't know if anybody has banned electric cars. Acha. Okay. Okay. What do you mean? Yeah. Yeah, it is. So I'm not. That's why I'm saying. I'm not saying all good things about electric vehicles. I'm saying there are some problems with electric vehicles. One is revenues, and the other is jobs. Has to be counted. Yeah, it's a balancing act.
What about the social benefits?
Yeah.
That we estimated?
One social benefit I have is the lower life cycle cost of ownership. The second social cost I have is greenhouse gas savings, greenhouse gas damages. I don't have air quality benefits. That would be third, productivity or health benefits. Those would be a third social benefit. Imports is also sort of a social benefit. It has implications for currency exchange. I don't know how do you monetize it. I don't know. What is the dollar social benefit of $1, 1 rupee less import? I don't know.
GHG.
Greenhouse gas, carbon.
Your previous paper, Delhi, you have shown that
Air quality benefits are
air
there.
quality.
Yeah, I didn't monetize it though. Yeah. So. 25 lakhs is based on 9 lakh buying the car. 300 kilometers. Yeah, that's probably, I will lower it to like 1 lakh kilometers and see. Then it will be low. Yeah. The battery will also need to be replaced less. So you'll also save on battery.
Any other question? There is no other question. Then I'd like to thank Deepak for this very enlightening talk. Actually, indeed, my car is 11 years old. It's a petrol car. I was thinking that it should be replaced with a new petrol car. But after listening to Deepak, I have changed my mind.
Oh, that's scary. You're taking me too seriously.
So that is the kind of positive benefits, especially the private benefits to me. Thank you so much.
No, I think everybody who's adopting is also providing a social benefit, right? I mean, everybody who adopts now is helping a new industry grow.
How many kilometers are you running?
70,000. Yeah, only 70,000.
I mean, keeping a petrol car and driving it less is probably better than buying an electric car and driving it more. If you're going to, so no, honestly, if you don't drive much, you're not doing that much damage. But if your personal preference is, I don't want to pollute, then by all means buy an electric car. So I'm saying do what is right for you.
That's why I have 100,000 numbers.
Yeah. So this was more based on taxis. Actually.
Yeah. So
Delhi-
500,000
Taxi. So this is based on taxis. In fact, a lot of my work, so when I started working with electric vehicles, I didn't start with cars, I started with buses. Then I went to taxis. So this is actually, inspired by taxis, and maybe that's why I kept that psychologically left that number there.
Yeah.
What about resale value for a car?
Yeah, so that's a good point. I think just to tell you right now, because of all the supply chain, I don't know what happened to the car market in India. I was trying to buy a car in America just 3 months back because the supply chain crisis and so on. The used car prices were like so crazy. And electric cars used car price was so high. So you would think people don't want to buy a used electric car because I don't know about the technology, but electric people trust the technology now. Nobody is concerned. It's not a good. The main concern is about charging, and so there is less fear about the technology failing, which was a problem before. Now, the resale value of electric cars is like insane because of high petrol prices. So petrol price worldwide is high, but you cannot buy a new electric car because of supply chain. No chips. So cars, I booked an electric car in January of this year. It's still not been produced. So it's being made in Germany. I ordered a Volkswagen car. I ordered in January. It's still not been produced because they are backed up. So used cars. So people who bought electric cars sold it for more than what they bought it after 1 year.
So thank you so much. Thank you all. Thank you.
Thank you. Really enjoyed it.
Thank you.